Right. Right. Welcome, everyone. And thank you for your time. I appreciate what you're doing. Our goal is to understand and master the IT industry, be able to run our company, or if you work for a company, be able to understand all the moving parts in a company so you know exactly when you go for an interview or you sit down for a job or you're doing consultancy, how exactly what you need to face the music, right? So, a little bit of um I'm going to keep putting these keyboard shortcuts for you, so start using them. When we say move your mouse up on your keypad, move up, move down. This 8 and 9, as you can see, they give you the history, right? So you have a bit of history that you can check on Linux. So these are important, right? Don't ignore these. So this is if you go up, if you press up on your key or you're down on your key, you can check the history of what commands you have typed, right? If you move right, you move left, you're moving on the actual command line, right? The actual prompt. So if you write a bunch of things over here and your cursor is sitting over here, you can go left, you can go right. Yep. Okay. But I would start using Control A, very important command, because if you're sitting over here, Control A will bring you over here. And if you want to clear everything up, Control U will completely clear the buffer for you. It will completely empty the line. It will remove anything that's in front of you. It's going to empty it like that. And if you have something written over here, for example, even if you have something written over here, and you press Control E, so these three, at least one, two, three, you should start using them. Eventually, we'll use Control Z. We are already using Control C. Control C is interrupt a process, right? So um, I hope you're using these commands. Okay, it's very important as a Linux admin to start using these keypads and don't ignore them. They're easy, easy. Control A, Control E, Control C, Control U, Control Z. You'll just memorize them after a time. Just start using them, and you'll be good. Let's move on, ladies and gentlemen. Let's get going. Right. So this we were talking about initialization files, right? Um, which was all what we did last week. Um, so there's a bunch of other things that are happening during the initialization process. Okay. During the initialization process, let me stop this. Wait a minute. One second, guys. I just want to be able to stop this and be able to write on it. Email recording. Okay. Right. So what we were talking about was initialization files. When a system boots up, because you know, a lot of people are thinking, why are we? If you go on YouTube, you won't find people talking too much about this, right? And that's why people learn Linux and they learn the icing on the cake. They don't really learn Linux. And if we spend the last weekend and this weekend just to get this out of the way, believe me, Linux is a walk in the park. So what happened is we said, a user sits on the laptop and or you know in place of a laptop you have a server, right? And you turn it on. It goes through a boot process, right? We have not talked about it, like I said to you guys, right? There is a whole thing, bunch of things that happen inside the boot process. We're going to talk about at some point in time, maybe in 2 weeks from now. Then the boot process eventually goes into system D. Okay, we said that. Okay, and then system D, like we said, is the PID one. Now this is what you call a simple model, and you don't need to know anything too deep about simple model. Okay, this is a simple model. very easy for anybody to understand, anybody to explain it in an interview, anybody to understand in their own company. So System D now has goes into something called, a, a target, a target environment. It's a target environment. It is set. Okay, so it has some environments it can go into, which has which has bunch of files. So this target environment, basically kicks off couple of things. We've talked about, you have your SSH because when a user is connecting into this, right? Um, right, a user like this. If you are the user and you want to access this machine, you would still need a keyboard and you will still need a monitor, right? And both the keyboard and the monitor will be connected to the server. So this is what you're going to be doing, looking and accessing a server, whether it's a laptop or a server. This is what you need a keyboard. You need some kind of standard input and sorry, standard input and standard output. We're going to come to that too next tomorrow. Okay, standard out. Okay, so your standard in. So you put you punch something in and you see something out on your screen. And if there is an error, we'll talk about that. So you using this process, you start the machine, you're watching stuff going on your screen. It goes in target environment. It does SSH, right? And we talked about that it goes into this. Eventually, we get into the initialization files, right? Now there are a lot of other things that are happening other than this initialization file, right? Because this is a network layer. So today we are going to talk about some other things that are happening, um, you know, in between, in between this initialization, because initialization files have to do with users. Today, what we are trying to study is user management. Okay, user management. That's our class today. How does Linux manage users, right? How does it use it? How do you manage users? Right? We know that it goes through a process, starts up, it gives you it gives a shell, a bash shell, and we found that out. So at least we are clear on how the bash shell is made available to us. And when the bash shell is made available, what files are in place, the profile, the bash RC files, they give us some say, a shell, right? And it gives us a path, it gives us an environment, you get path, you get a dollar path, you get an environment, you'll get an environment as well. Okay, so this path and environment allows us to do what exactly what everybody's been doing. So if you open a machine and it says over here, your prompt root, okay, and you are a root user because are you using pound. You're not using the dollar because we're going to get to the dollar very soon. Okay, dollar sign. So when you start typing something, you get an output. Okay, right? You're putting in your keyboard an input, and it gives you an output. If you don't get an output, you'll say command not found. So we have been talking about that. So today we are going to talk about that. Once you're inside the shell, right? You start doing a number of things. You have something called user management, right? User management. You are a user and you are a root user, right? And you've gone through a process. System D has identified that there is a user called root, and it now makes a shell available to you, right? You have a shell. You have a shell in which you can work in, kind of like a notepad, right? Your book. In the good old days of no computers, you had to write in a book. If you went to school, you were doing a job, you would have to have a notebook in your hand, a pen and a notebook. So now Linux has made it a notebook and a pad available to you. And you start writing things and typing things and getting an output. So one of the things is that root is a user, right? There is within this we have what is known as an operating system user, right? Linux operating system user. So and then we have this operating system user mapped to what is known as an SE Linux user. And today that's what we're going to study. I'm going to give you a bit of an overview as a Linux user. Okay. So when the system boots up, does a system D, it does something as well. There's an underlying within the system D, within the system. There's that the kernel has got. There is because this is all. I mean, sorry. Here it is all C programming, right? C language. We're not worried about that. We're not looking into that. That's why when C programming has what is known as its binaries, right? We hear about bin folder binaries. So if you ever open a command and did a cat of any like a password command, right? It's going to give you a bunch of gibberish, right? It's going to give you because those are not readable by Linux, right? Your shell cannot read that. Your shell cannot translate what's inside it because it's a C program, right? We are using the bash shell that does not read the C, just like bash is not going to be able to read a Python program. But within the shell, we can run Python. Okay, within the shell, we can do a few things. When we install a Python package, it's going to read that Python files as well, get you into the Python environment in and out. We're going to be doing Python in this class, and you guys will love it. So that's why this is all important, what I'm saying. Initialization, this process. I keep bringing this process in front of you so that you understand that, okay, so this is, we didn't talk about target environment, but when we talk about the boot process, we will talk about that. So what we have talked about so far is very simply that it initializes, you can see the PS3 command, and basically it goes here and opens up the port for you, like we said in the airport, and then it allows initialization and creates the files. So we are going to learn about the fact that uh, the users that we are talking about are all Linux operating system users. And then we have a safety mechanism called SE, right? So SE Linux users. And when we come to SE, we'll talk about it. So let's get started. Um, give you a little bit of roadmap of where we are going. Um, so imagine that you have your, let me erase this. Uh, You can take, if you guys want to take a camera and take a picture, you're welcome to do that. But this video is going to be available anyways. But people are saying that the CMS is not working fine. We're going to fix that and put the videos correctly if you can. Apologize for that. So now, one of the things that we have been studying all along is that there's a file system here, right? You have a file system. You have files, you have file system. Now, this user that you have called root, right? This user root, right? This user root can move around this file system, right? You can go anywhere, go here, go there. So by default, anytime you create a user, it's a Linux OS user, and it has an identity given to it. Okay, because one of the things that we talk about all the time is IAM, is new way people are in a resume, a job description. Do you have a IAM experience, sir? Okay, and people go blank. Yes, I do. Or tell me what you know about IAM. User ad. Well, that's not IAM. Okay. If your answer in an interview is that I learned in Linux class with this uh, NIT folks, user ad, right? Or I mastered a few flags, and you think this is IAM, you're not going to get the job, right? So understand that very clearly. User management has a bunch of things. One of those things is, yes, user add, okay? And we're also going to see how to delete a user, right? And what are the different files that are created within user management, okay? So there is user management, okay? Don't get that wrong. And then there is IAM. User management is part of IAM. I stands for what? Anybody? What does I stand for?
Identity.
Identity.
Identity, identity, identity. Right. Identity. If you have no identity, you are not going to be working anywhere in Linux. You will not work anywhere in any job. They have to have an identity. So, identity, uh, and then next thing is access management, AM. Understand this very well. Okay. Don't rush because you can do the labs, learn how to create a user, delete a user, modify a user, right? Understand even the files. That's the easy part. Next week, we're gonna give you enough work to just go inside there and do this management part, this management. Okay. Um, but identity and access. Okay, access. When we say access, well, how does Linux define access? Okay, so access is something we're going to talk about. So I'm not gonna speak about it here, but I just wanted to understand that our topic is IAM. Okay. Now, a lot of people see jobs in AWS, right, or Azure, and they say, well, do you have IAM experience, right? And believe me, 99% of the people who have gone to any boot camp or are in the IT industry today, unless they really truly have done this work, most people cannot answer this question clearly. You ask, what's IAM? What do you, we have a bunch of people here who have done some cohorts here. Anybody who has done IAM, please, I would like to put them on a hot seat and ask them. So, what do you mean by identity in Linux? Okay, identity. What is the identity card? You say root, and there's a user, and I'm a root user, and there's standard users, and there are five type of users, and you memorize all this. You go in the interview, and they still don't give you a job. And somebody says we went to NIT, and they asked me a question on IAM, and I was unable to, I answered correctly. Um, I told them I can do user add, user delete. I can do a bunch of things, and there's so many users in Linux, and this file and that file, and they weren't really happy with the guy's answer, right? Because you have to understand where's I am beginning, where is the start of this I am, right? And that's what we're going to do now. So I'm going to go ahead and delete that, please, right? So what we have, ladies and gentlemen, we're going to run through this a little bit. If this will allow me to. Okay. So when you log in, it's like you get to a building, right? And you find the guard at the front gate, which is the Etsy profile, okay? Which is the orientation guide inside of the lobby. But there's a bunch of other things that are going to happen. What else is going to happen? What's going to happen is you're going to have you're going to have authentication. You provide your credentials, right? Uh, Somebody has to check a password, right? Whether you are allowed in that building anymore or not, or somebody said, well, this guy's last day was yesterday, they should not be allowed today. So there's some authentication that has to happen. Um, and we have talked about all of this a little bit. Okay. I've just put this slide here because I just want to warm you up. You can go read on this. Uh, you can go through a little bit of this, sourcing the profile. We have talked about this, uh, and we have done all of this. Okay, but two things you need to keep in mind uh, that we are going to do today. And let me get to the next one. Right. So don't worry about this slide too much. Uh, the goal of this slide is to warm you up when we really get down and talk about networking, different layers of application layer, networking layer, how when you come into a system, the networking layers work. And these are based on those layers. When you see this uh, different type of authentication. Why? Because when you work for a company and you're troubleshooting a problem, this slide becomes very useful. In 3 weeks from now, this slide will become very useful to you. But for now, it's a warm up. Just read it and enjoy it. So I am user management overview. In companies today, we have Active Directory, which serves as the backbone for managing users. 1 second, guys. Let me get some water. I'll be right back. Right. So let's move on. Everybody's ready to look at identity management, right? So let us take a look. Right. So what we have Active Directory. When you get a job or you all are sitting on Windows machine, um, so when you switch from a Windows machine into a Linux machine, Linux does not recognize Windows Active Directory. It doesn't. That's one fact you should know. Okay, if anybody ever gets into the authentication kind of business within a job, Windows and Linux are two different seawater and salt water. Okay, so Windows is the salt water, and it, and Linux is the sweet water. Okay, so they don't mix. So the only way these barriers can communicate is through LDAP. LDAP is a protocol, and the LDAP protocol, that's all you need to know, right? So you have a company, you have a bunch of people working. This is typically how a lot of companies are today. People in cubicle space or open spaces, they're sitting down, working as a team. And uh, so a user account, this is an intro, right? A user account is a systematic approach to track and monitor the usage of system resources, right? So you have the root or super user. This is like FII stuff. Username is used to access the user account. Sounds very simple, right? But we're about to drop the facts on you. So this is just a Linux operating system user. When you create an account, and you have to have an account, definitely. You have a service account like Oracle. Every time you download an application, it's going to have a service account. Any Nginx server, and then with every account it comes a UID, right? Used to authenticate, track, monitor the activity of the user. That's what Linux uses, right? But this UID has a backend as well. Even though it's a backend, it has another backend. So let's move forward. FYI, um, you have the super user root, you have the normal users, um, and you see that it says 500. Well, this has changed now. This was in older versions. It used to be 500 to 60,000 users. I think 4 million users can be added into Linux. Universities, colleges that are currently using Linux uh, could have a lot of users. Large companies like Microsoft that uses, they have, some companies exceed the 60,000 number. But Linux by default says you can, and we'll talk about that too, right? Um, then you have the system users, like when you talk about Oracle, Apache. So where do you get this value from, right? That's what we're gonna see coming up. So you have normal users. This is a user created by root. Network users that logs into Windows Active or LDAP. Don't worry about that. User, nobody's gonna ask you. So we're not too concerned about item 3. We will see item 4 when we do our cohort. I mean, we do our projects. Then we are also going to look at the pseudo user, not today. We're going to come to the pseudo user that has the admin privileges and the pseudo files, and how do we change them. But I'm not going to touch any of that. I don't want to confuse anybody into the pseudo file and how to change the pseudo file and get stuck with the pseudo file. and not able to, it wastes a lot of time. If you understand the first two, the last two are real easy to grasp and use. Okay, so we'll focus on some simple stuff. Now we have practiced a command called the W command. We have also practiced the who am I, right? Who you are. But the W command gives you these one, two, three, four, five, six, 7 columns, and basically it tells you the terminal you're in, the time you logged in, how long you have been idle, uh, the CPU time. So you see the words, don't look at the J, the CPU usage, okay, and then you have the anything that's happening in the foreground, all processes. So JCPU is all your processes running, and PCPU is the so you don't need to worry about all that. Nobody asks that question um, and the only reason I pulled it up is because when we do performance testing, we're going to need this top command, the vmstat commands. So the value of this output, right, is for you to understand, because a lot of times you go at a job, you've gone, you run the W command and you're looking at all of this and you're thinking, well, what the heck? So I want you to understand and be able to read these columns, right? What time did you log in? Who logged in at what time? Okay. So your manager asks you a question, well, how do you know, um, user ID X, Y, Z, which happens to be maybe Bob. What time did he log in, right? Now they're not asking you this question about why he logged in or to check if you're logged in. No. The reason why they ask this question is because if someone made a change in the system, if the change came before you logged in, then it's a way to eliminate who that user is. So a lot of testers come in, a lot of developers come in, they make some changes, the environment is not working. How do you check that? I'm going to give you the magic command at the end of this class. Okay. You can open the it's the last slide of today's discussion. How do you know uh, more details about a particular user, what time they came in, what did they do? And it's needed sometimes, not all the time. You can check in the last log, right? Which will give you a bunch of information. You can just run these commands. That's all you need to know, nothing to worry about. Um, if you run the W command, which we have talked about, um, -u is giving you the user, who -u, okay? If there's a particular name you want to put after that flag, we'll do a bunch of labs on this, and you want to we'll talk about this coming up. So this is kind of warming you up. Um, to understand how to kill a user. Why would you want to kill a user? Well, maybe it's a process that's stuck. We're going to do a bunch of tickets and you'll understand that. So understand very simply that if this user, let's say Bob leaves the company, and after he leaves the company, you don't want to delete all his files, but you want to delete him as a user. So
Brother Nadim, can I have a question?
yeah, go ahead.
This command access to everyone, all the user, or is just the admin or root commands?
These are all I mean, everybody can access these and see them. But do you have the permissions to kill them? No. If you have a regular user, you have to have the word sudo in front of it to kill that. That's a very good question. So your dollar sign, you say आप dollar sign देख रहे हैं? So you have the dollar sign and you have sudo. This shows that
Yeah, yeah.
this user is not a root user. So the only way they can execute this command, which we like I said in the path on the big initialization, we all users cannot do everything. Some users can, some users can, but the pseudo user is given the root rights. That's why putting sudo and then running this command, yes, they'll be able to execute it. They'll be able to kill that process. So now, so how do you check details about a Linux OS user, right? This is something that is very interesting. So let's go in here and see if we can do SSH at 192.168.1 dot. I'll take 97. I'll take this user. Okay. So I've created this is user, whoever has user 97 IP, I've actually created something for them. I have a practice lab user. Okay. So we have tested the W command. We have tried the who command, and we have, who hyphen u command. Okay. You can see the differences. All you have to do is just run them first. Okay. Last log, right? Um, who logged in? This is just logs. So because we haven't talked about logs, when we get to logging and how important it is to see who logged in, never logged in. Well, this is never logged in. Like, let's say you got 15 users, right? It'll tell you their IP. It's going to tell you at which port are they remote or are they coming from a local terminal on site. Okay, so SSD, Ronnie, these services never logged in, Ibrahim, Alice, and John. So if we go ahead and say SU Alice, right? So Alice is in, and now if you and SU Ibrahim, SU, oh, okay. I don't want to touch this. The gentleman's machine. SU John, okay. ABC. Oh, good. So we have now if we do last, uh, I think we can do last log. So you can see that they logged in at the time and everything is all you can see who's logging in, who's not. So it's a running log, right? So now simple stuff, nothing that you need to sweat over. The main thing that we're going to do now is run um, something that is cat etc login.defs. This is an interview question a lot of times, and when talked about initialization, this is actually not the user initialization, right? In part of the user management initialization. I remember I said to you guys when I was drawing my diagrams, I said to you that when system D kicks in, it's bunch of services that come on. I drew a diagram like this. One of them was SSH, one led to the bash. And then you have authentication. Authentication is also one of, so the multiple processes SSD is going to bring on different services within the system. And one of them is this logdefin. Okay. So what does that do? What that does is that that when a person's notepad or shell is loaded up and you get your prompt over here, right? This command over here, it gives you some. What it does is it's part of the user management. Okay. So what does it give you? Let's take a look at what's inside this file. All right. So cat is to read, guys. Don't forget that. We're too late in the program now to know that if you don't know cat. So we hope that you understand what cat command is. And if you don't know, we're going to drop a few more file operations work coming up this week, which is using these commands. So when you cat into this, okay, uh, um, and scroll down, it's going to tell you a bunch of things. Now let's go back up. So um, let me go down. Things that you want to change, your mail file. We're going to talk about this when we do a project that you want to receive an email alert, how you can set up email alerts in the system. We're not going to talk about that now. So let's keep on going. Environment path. Now, don't confuse this with the initialization path, okay? Because shell startup files, when we're starting up, I said there are a bunch of system D kicks in bunch of other things that are happening, right? Don't confuse this with initialization files. Those are files that have to do with the user. These files over here have a total different purpose, and don't worry about it. Okay, it's a path. The system needs a path. Um, we're going to talk today about the UMask value coming up tomorrow. We're going to talk about UMask. Okay, what is UMask? and then password aging controls, right? Password maximum number of days, how long, minimum days, minimum length, uh, the warning that you're going to give. Um, the default right now is 9999999 days. Minimum is 0, pass warning age 7. Okay, if let's say the maximum days was 40 for a contractor was, or for everybody set in the company is 60 days. Every 60 days you must change a password. So you got to replace that by 60 days, right? And then 7 will be the warning. Like you have 7 extra more days before the password will stop working completely, right? So these are the things you all know, simple stuff. Okay, there's nothing a rocket science about this, but I want you to understand how to read these files. Minimum, maximum values. Okay, in user add, very important. When you all typed user add, which we are learning, it said okay, minimum, meaning the first ID that that the system will set for that person is 100. Now, if we come back here, I said something over here that this is 500. You can change it to 500 if you want. This is what RHEL 8 used to be, RHEL 7 used to be. RHEL 9, and moving forward, has put the user IDs at 1000. But it's your company. If you like the IDs to begin at 500, that is fine. Okay, you can put it at 1000, right? And you can go up to 60,000. But let's say you're working for a large hospital, right? And you need more than 60,000. They're all over the country. Your clinics, like Davita, which is like a kidney dialysis center, or clinics that are all over the town, city, and they need more. You can come and change the value here, and then Linux is going to allow you that. So those are some of the things. Then the group ID mins and max is the same way. You can change those. Login timeouts. We're not going to go into that right now. Uh, it it basically goes through this file. Okay, this important file. So okay, now this file. This is the first thing you've learned about the Linux OS user. Where do we find? I want to ask, and somebody should answer and read what are you seeing on the screen. If you're asked this question, where do I change the limits of the number of users? Where can I make some modifications to the logins? What file is it, ladies and gentlemen? It's in front of you. Somebody open the
Login
mic.
DFS.
Right. Login
Login.dfs.
dot. Thank you, sir. etc forward
Login.
slash, yeah, etc login dot def, and DFS is fine. So etc login dot DFS. You can shorten it to defs or DEFS file. Okay. So um, this has come up in a lot of questions. Sometimes people are you get somebody who's working and they say, "Oh, I know you have a lot of I see that you have IM." Remember now, everybody, all of you that will come out of this cohort will be shown on LinkedIn working for a company for at least 2 to 3 years. Okay, all of you. If you already have a job, that is great. If you don't have a job, you're in any part of the world. Um, Bilal Khan is working on an email solution. Once our mail servers are up and running, all of you will be given an email. You will have to log into that email, and you need to activate your email, and then you will show you how to go on LinkedIn, and then you have to use the email to verify your identity. That yes, if you say on your LinkedIn you have been working for an IT company for 3 years, and that happens to be us, well, the only way to verify that is through our own domain and our emails. So those emails are coming out, uh, and then you're going to sit with a very big smile on your face going into your interview, working with us. or working on our projects that we are trying to pull in. And if your resume is put in front, so for example, Asim Nazir, right? Hassan, Adelovo, all of you guys, in about a couple of weeks, like I said, you will be showing on LinkedIn that you have 3 years of experience working with us. You're part of a group of company that has about, you're working with 500 employees. Now, that's what we are bringing you into. That is the value of this cohort to you. Okay. And so if we are going to put our name behind you, that means we are going to stand behind you. I hope you understand. Does everybody understand what I'm saying? Any questions there?
Yes, you're okay.
Okay, good. So as much as everybody's worried about, I'm taking this very slow. There's no Urdu class today. We'll take it slow. In about 5 minutes, we'll take a break. Everybody take a 10-minute break. Come back, chill out. We will take our time. We have 4 weeks of Linux. We have knocked out 1 week. We have 3 more weeks, and the train will pick up the speed. Okay, but I will not pick up the speed until you all understand. That's why I keep saying initialization file. By now, you should be very clear. At least you should understand that. So now we are talking. Look at the heading of the slide. The heading of the slide says Linux OS user, operating system user. And you're probably asking, what the heck? Hold on. Yeah. So who's an operating system user? Now you can say HC login defs is one of those. System D, the system D PID1 kicks in. One of the places that is system D will also go and look will be in that folder, right? We'll make sure to read all of this information out, right? Because if the root user, for example, needs to create a user add like you all did, okay, then login defs is a file that's already loaded by systemd, and it is a configuration file. Configuration is the word that people always keep wondering, well, what is configuration, right? So where are we at? You seeing my screen? Yep. Okay. So we are talking here to how to configure, right? Configuration. So when the process starts, it goes into some configuration files, how your system is configured, how it is supposed to give you what you need for it to do for you. Okay. So that is what we are doing here. All right, let's keep on going. Now, let me clear all. Okay. So what if the number of users have to exceed 60,000? Simply, all you have to do is user add -u is for the flag for users. You want to up the values, let this be the 75,000 user, and he will be Bill Thrasher. Or simply you can go into the etc login defs and change the value, and you're good to go. All right. Let's go to the next slide. Now it starts to get interesting. Okay. Very interesting. And you guys need to pay attention to the stuff that we're about to do here. All right. Let me close any. Okay. Let me make sure everybody's there. All right. All right. All right. Great. So we have a command, ladies and gentlemen, identity. Identity. How do we look at identity, right? The interview question was, do you know? क्या आप जानते हैं? Do you know about? क्या आप जानते हैं? IAM.
Sir, we are not seeing the screen.
Are you not?
No, not on
No,
my
I'm
thing.
okay with that. I can see
I
it.
can see my on my end. I can see.
I can see.
Yeah, okay. You can see what I'm typing?
Ah, yes. Okay. Now it's clear.
Rasul, Do you know about IAM? In Urdu जैसे क्या आप IAM के बारे में जानते हैं? Okay. Do you know what we're going to talk about? So, well, this is an interview question. If this is an interview question, ladies and gentlemen, this is how you're going to start your story. So I'm going to tell you your story, and please don't forget the story. The first thing you'll tell them, yeah, I do. I've when we talk about IAM, which is identity and access management, identity and access management, right? So we are going to talk about identity first. First thing is identity. So if somebody says, "Do you know about IAM?" Tell them in Linux. Well, I used to work. I've been working with Nexus. I've been working with NIT for the last 3 years, and I was working with a team that actually was part of the where we had to work with the IAM team. We had to work with the IAM team. You see, Tom, um, in Linux, if you put in if you just type in ID, okay, and you put the ID of for, let's say, for root, and you put ID for Alice, and you put ID for John, right? It's going to give you an ID, okay? It's going to give you an ID. ID for root, here's the ID for root. The UID is 0. This one, as we know. Why is this 1001? Why is this 1003? Because we probably have an ID Ibrahim. This is Ibrahim's machine, I think so. Sorry, I think ID Ibrahim. 1001, 1002, 1003. Three IDs. Okay. Now he's created three IDs, which is what Linux is giving them. So every time he does a user add uh, IO. So user ID IO. User add uh, Ardelovo. ID Arde. Oh, sorry, I misspelled it. Forgive me about that. So you can see as we are adding users, something is happening in that file, right? That file, which is we talked about, right? What is that file, guys? I know it's not easy to remember that. What is that file that is giving us all this? Uh, uh, it's checking and giving us. It is your etc
at login dot def.
login.dev. So when we do user add, one of the files, this is not the only file, one of the files, it goes here and says, okay, if I need to give this ID, it is defined as 1000 to 60,000. I've already given 1001, 1002, 1003, 1004. So I'm going to give you 1005 by default. I can change that, and I just showed you all. You can say, let's say let us say that all the users in your company, right? In a company, you have a dev team, okay? You have a dev team, you have a developer team, you have a SIT team, you have a production team, prod team, and you have built multiple teams. Let's say that the user IDs are here are 1000 to maybe 5000. Okay. And the new user, let's say, that's going to come on board is Let me see who we got. Okay, if Akeem, Usman. Okay, Akeem is the one. Akeem is going to join the production team. Akeem is going to join the production team. So Akeem is coming here, and the IDs for this one. So let's say SIT is 5,001 to let's say 10,000, and let's say production is 10. Let's keep it simple. Let's say 5,000 to 7,000, and this is from 8,000 to 9,000 is production team. So you can decide how you want to take what's given in this file. They're not Linux is not telling you what you need to do. It's just saying you can have that many users. Company can decide, okay, let when we get a new user onboarded in a company, they are going to be working with this team. So their user ID that is going to be created, their UID that we're going to create for them needs to have an allocation that we're going to say, okay, we're going to have a user, we're going to add them in here, or we're going to that user is going to be Akeem. Let me keep it small. Akeem and and sorry, where is it? And his ID is going to be, let's say, 8,001. Akeem. So this is what these flags do. Okay, this is what these flags do. That's all. There's nothing big. If you just said user add Akeem, it's going to pick up the next in the line. It's going to go to 1,006. User add Umer. User add Khadija, Nadia, 7, 8. It's just going to follow the sequential order. But if you want to be specific, okay, let's put them under the prod group, under the production team. So minus you, 8,001, and you basically every team knows what IDs are available to them. Okay, some people have contractors, they've joined, some have left. So that's what I showed in the last slide. Um, let me clear that all. Okay. So if I go here and I say user add minus u, okay, 8,001, not 1,005, and Akeem. Now if I do the ID of Akeem, guess what? He got 8,001. And we'll delete all these users too. I'm using somebody's IP here. I don't know who has this IP I'm using. I'm sorry, but I'm using your machine. I'm going to clean up your machine in the end, and I'll show you how to do user delete. Okay? We're going to delete all these
Brother,
users.
can I ask a question?
Yeah, go ahead.
Once we create a user and give this UID, and then, for example, he gone or he terminated or he left the project. So what gonna be happen about UID? Is gonna be still there or available for the next user, or is it be there forever?
Right. So, very good question. We can answer that question right now. So we will knock out this slide. So I have a very, we have this flags we're going to talk about, but delete a user. You have one option. Very good question. This is a question that comes out that everybody should know. If somebody leaves the company, a user, initially you don't want to delete all the files. You know why? Because they're working on a project. So let's say, Asim, you hired somebody, a developer. They come back after 1 week and say, Asim bhai, I love working with you, but I got a new job and they're paying me far better than what I can do for you on your project. And he leaves the project. So he gives you no he gives you notice. Everybody who has a co-host, please just mute any background noise, please. Uh, I think you are there, Khadija. Also, I've given you the co-host and Nadia and anybody. Just please keep an eye on the sound if you don't mind. Okay, delete the user but keep their files. मतलब है कि user has left the company, and but you don't want to delete all the files because they're working on your project. So you just don't go and delete the user, because if you do, you're going to delete all the work they have done. So you never want to do that. So you just do, if you do user delete username, okay, uh, it's going to keep their files. Okay. You want to delete the user and their files, you have to put the -r flag. So let's say your user was Josh, Josh out of India. Okay, he was working on this. So user delete Josh. If you did that, yeah, you're gonna delete everything for that person, but you will not delete the files. The files will be safe. If you did -r flag recursively, which means you remove them and remove all the files and their files. So that's the difference between the two. So if we want to take all the users we have created here, okay, let's look at the home. Where do we find the users? Home. Okay. Now I have all these users, right? Let's look at user Tayo. Let's look at user. Uh, well, Ardelo's name is mistakenly put in there. We want to fix that name. Okay, we created it. So I can do user delete. Okay. Now I would use -r because there's a typo error in the name was created. I gave somebody's name. You're sitting there. They asked you to add 10 users, and you added Ardelovo. You misspelled the name. So, oh, okay. Well, let's delete the user. User delete Ardelovo's mistake. We have put here. Now that would be a problem, because if I do that, all his other files are still going to be there. Okay, and so if I do user -r, okay, ooh, -f.
I think there's no space between hyphen and R, I guess. I'm not sure.
Oh, there's a mistake there. Okay, sorry. I'm typing with yeah. Thank you, thank you. You are paying close attention. There we go. So now we can do Adelov is gone. But let's look at Akim. Okay, if we look at user Akim, um, uh, for example, we said user delete Akim. Okay, I did not use a -r. I want Akim has found a wonderful job, and Akim wants to switch jobs. He puts in a notice. I'm leaving. I got another job. I'm moving on to, and you throw the welcome party to him and thank you and everything. He was a great guy working for NIT. And we say, well done, and we wish you all the best. But I wouldn't do this to Akim, because Akim was in a very lead role in our company. He was leading a team. He had a lot of stuff he was working on, but he has to move on. He has got some much greener pastures to go and dig. So now I'll just go user delete Akim. Okay. Now you see, now when I did user delete Akim, Akim hasn't gone away, but Akim as a user has gone away, right? So if I do, Akim was trying to log in, it'll say user Akim does not exist, or the user entry does not contain all the required fields. So I have deleted Akim, but the reason Akim is showing here, because I didn't say -r. -r means recursively. I didn't remove his files. So now I can actually, I'm root. Who am I? I'm root. So I can actually go into Akim's folder, and let's say he had a file called, uh, so Akim had a file called project app, and I don't want to delete that file because project app has a lot of bunch of directories and app. So now what I've done is, uh, now, but if I'm done with all Akim's files, we're going to learn that let's say we want to take everything Akeem has worked on and we want to move them to some other folder, right? So one of the things we have to do is we have to cd into Akeem's folder, and we see that he has got a project file that we need to move it to somewhere. So where do we move it, guys? Where should I move it? This is $1 million question. Well, where do I move it? Well, first of all, I need to understand the file system structure. Okay. A lot of companies, what they do is they come to the root directory, right? This is the whole Linux file system. Okay. If anybody is following us, we did CD, where am I? Or who am I? I mean, sorry, PWD. I'm in a folder called root, the home of root. Now I would like to move to a folder, to a directory, to the top of the directory system. That shows me that I'm now at the top of the directory system. Now I would like to view what's inside the directory system. Okay, because it says, where am I? PWD. Before I was in my home. Now I've moved from my home one level up. I'm sitting at the top of the directory tree. I want to see what's everything in my system. It's the 5,000 feet overview, 2,000 feet. You want to see everything that you have, that your eyes can see. Okay, so I can go and just do LL. Remember, we said if you type in alias, you have a bunch of aliases. That's why LL stands for LS-L for those who have missed that class, but that's fine. So now I can type LL, which is long listing. But do I really need that long listing? No, I just want a listing. So simple and short, I just want to see, oh, okay, these are all uh, folders. I would like to go ahead and create a directory called backup. Okay. Now if I do ls, I have a directory called backup. I didn't have it before. I have it now. Now I go into CD into Akeem. You guys are working for NIT for 3 years. I hope you understand that. So at least a 3-year user should have very good understanding how to manage files, folders. So we are managing a user. The user has moved on to a greener pasture. And I hope all of you who are working here move to greener pastures while still connected to us. That's our goal at NIT. So you're 3 years working for NIT. We're managing something for us. Now we say, okay, um, um, Akeem has moved on to greener pastures. Uh, let's go to Akeem's folder. Well, I can use the relative path because I'm sitting here. Since I'm sitting inside here, I can see, what can I see? I can see home. If I'm sitting outside and PWD and I do ls, I'm not seeing home. When I do long listing, it shows me this is what I can see. So unfortunately, I don't see home here. So I would have to go and use the absolute path. CD home is the absolute path. Okay. But what if I went into slash and I said, and and now if you want to know about I'm sitting inside this folder, and when I do ls on this folder, when I do ls on this directory, the root directory, when I do ls on this directory, I'm seeing all my directories, right? So I want to go into home. I can just use the relative path. I will not do this. I don't need to do that. I just need to say cd home. Okay. Now I'm looking at Akeem. Let's go to Akeem's folder now. cd Akeem, still relative path. Why? Because I'm sitting in home and I'm checking home and it's showing me Akeem is there. So from home, going into Akeem's home is a relative path. I don't need to go cd home Akeem. This is a full absolute path. No sense of doing that. Okay. I can just go cd Akeem. Okay. So now I'll do long listing. Why am I not doing LL? Well, when we get to file permissions, this becomes very important. We're not in file permissions today. We're in the user management today. LS, LL. Okay. So he has a file called project app. I would like to move this file, okay, project underscore app to where? / backup. Now, if I do LL, the file is gone. Okay. And if I go CD and I go LS and I go, let's go into backup and I do LS, there's your project file, LL. There's Akim's file. Now I've moved Akim's file into a backup. Now that I've moved Akim's file out of the backup, what do I do now? Okay, next NIT. I am your boss. I ask all of you who are working for NIT. Okay, you're working 3 years. So, guys, you need to go and delete Akim. What is the first question? I want anybody to open the mic. Well, I want to delete the user Akim. What should I do? Should I delete him and all his folders? Yes or no?
No.
No.
Yes, you can now delete because you
Yeah.
have moved his file to a
Very good.
safe.
I can move these files. I can delete him. Thank you. Very logical, very easy. Linux is very powerful. So let me go now to CD home. Okay. Akim is there. Now I can do RM
Yes.
minus R Akim.
Okay.
I would not say just Akim. I must put the flag R now so that there's nothing. Why R? Because uh, if I go into CD Akim and I go ls hyphen al, I still have the initialization files. I still have the initialization files. Okay. So these are the files that were created at initialization. They're not gone yet. So I have to do user delete hyphen R Akim. Now does not exist. Okay. Interesting. Now I can remove him recursively. If I try user delete Akim, it says it does not exist. Okay. ID Akim. We can't do that either. Now the beauty, ladies and gentlemen, is the system has removed the ID. When you did user add and it gave an ID, there is no ID. The system does not recognize anybody in the system called Akim. That's why Akim cannot log in. That's why Alice cannot log in. Okay. Now at this point in time, we just want to delete. So what do? We do a CD LL, CD home. Sorry. Simply, we can do RMDIR because now nothing more than it's not even a user anymore. It's just a directory called Akim. Oh, directory is not empty. All right. So what do we do then? RM hyphen RF. Why is it not empty, guys? I removed his file. Why is it still showing me that its file is not empty?
There are some hidden files out there.
Very good. Very good. Excellent. They are hidden files. Very good. They are hidden files. And we check them. They are the hidden files with the dots, the dot, the dot, the dot, the dot, or hidden files. That is why RMDIR is not working. Fail to remove Akim's directory is not empty. So we have to clear and we can go CD dot one level up, LL, we can do RM hyphen RF, Akim, And now we are good. Now the system is clean. We will take a break. Ladies and gentlemen, I hope you're enjoying this class. We are getting into user management. We're going to go very deep. You're just scratching the surface of this. Okay. And now at least you understand how to add a user and how to delete a user. Now I've added Tayo and Alice. So all I'm going to do here is user delete hyphen R Alice and Tayo and John and student. Uh, okay, user. Maybe it doesn't allow us to do it all in one. Okay, so we have to do it. Rel 9 doesn't allow that. Okay, Rel 9 doesn't allow that. So they've removed that feature where you just put 20 people and then you deleted them. Why do you think they did that? They did that as a safety. You don't want to delete uh, 10 people at the same time wrongly with hyphen R. So you have to do one step at a time. Okay, that's why the logic is put that way. Okay, John. Okay, let's. Uh, so I'm not going to touch Ibrahim's folder. I think Ibrahim, who's sitting in this class, I think I'm using his IP. Um, but so this is the machine. So, ladies and gentlemen, we'll take a good 10-minute break. We'll come back and we'll dive into SE Linux. I hope you're enjoying yourself and thank you for your time and enjoy your break for a good 10 minutes. Right, let me see. Whoa, let's see. Where's that? Stop sharing. Yeah. Yeah, Kim, you're going to be a rich man. Trust me. I give everybody just one more minute. So we were at the top of of this discussion of identity. So we said if you run the word ID, basically you will get what's known as an identity. Okay. So we've kind of gone a bit far, looked at logs, look at how to, but the main thing that we're going to look at today, right, is uh, this particular command, right, the ID command, right, which we looked at. Um, one second here. Where are we? Where's everybody? Okay. Okay, great. Great. Now, when you type in just the ID command, right? We have been typing ID root, ID Ibrahim, ID student, right? But what if you just type in, remember we said identity? So part of identity management is Linux looks at ID. Sorry. Oh, ID. Now, when you type in just ID, it tells you obviously the root user is 0 because that's in, you know, initialization. It has a group ID. It has the groups the root is currently in a group called root. But there is something here that you need to gibberish that doesn't seem to make any sense that we need to make sense of, right? And this is exactly what that question is about: identity and access management. Okay, identity and access management. What is happening here is that you have, let me see my annotation one more time. Okay. So what is happening here is that you have a context. Okay. a context, right? Context is a story, a context, meaning you have this here is all of this over here is the text, and all of this over here is the context. So if you're reading uh, anything and you have a bunch of things written in the document, right? There is text, and then this whole thing is called the context. Okay. If somebody says, I will kill you, okay, I will kill you, okay. Now, if you don't have a context, what does it mean? This may sound like something very harmful, or this may be somebody saying, I'll kill you there. You're working on your Linux machine late in the night and you have a process, okay, that is stuck and you're upset. You say, I'm going to kill you. You're talking about the process. You wouldn't know what you're talking about until you have a context. So there is something called text and there's something called context. Okay, I hope you understand the meaning of the word we are saying context. Okay, so you have text and you have context. Now, I hope you're very clear. So context is being defined by this. So all this stuff over here, right, is part of what is known as the Linux operating system, OS user, right? But Linux has a thing called the SE, which is known as security enhanced. Okay. Security enhanced Linux. And this context that you're looking at here, sorry, let me remove that. This context it's talking about, the context is SE Linux context, meaning that when you say user add, okay, Linux operating system has all these files we have talked about, right? We have all these files and folders we have talked about, initialization files, and we have the login defs file, and we're going to look at ch file, and we have so many different user files that it goes into and check, oh, give him this, give him that, this is this, and that, and finally you have a user, and that user has some kind of an ID, like ID 0, in this case, which is the root, okay? As a file that tells you who is 0, who is 1001. We talked about that, right? So this is part of the operating system Linux, okay? OS. This is what the OS has done. But Linux has another system in place, okay? And this system is called SE Linux, right? Which is secure Linux. It says that you give me this user, okay? This is the user here, okay? And the user here was student. We'll use that student, okay? Now, um, I have a mechanism in place, SE Linux. This is SE Linux, right? And SE Linux says, look, I have a system in place, right? That the designers of the kernel have put in place. That SE Linux is a security enhanced, meaning that for every user that is added, Linux advanced, and if so, either you can enforce it, you can enforce this, and we have a command called set enforce. We're not talking about that today, but we're just letting you know. enforce, enforce. So let's say this is your airport, right? This is your airport, the example of the airport. When they were building the airport, when you're building the airport, it looked like this. Okay. Uh, let's do this. Let's do this. When they were building this airport, right? This user, whether they are root, whether they are this user can move about the system, can go to different paths, different places, can access different things, different files, right? This person can move around. When the construction was going on, the construction workers, the foremen, project managers, construction crews, everybody was moving around freely within the system, okay, including root, including root. Okay, root was also able to move around freely. But once you got the building ready to go and secured, you have something called SE Linux that kicks into place. And SE Linux says, look at the ID, look at the ID, right? And tell me what do you see under that ID? Because the real ID is the context of that user. And if we realize that the ID that this has given us, let's say for a user, right? This passage, when this user now comes across here and crosses this boundary and comes inside into the same environment again, and SE Linux is enforced, meaning security systems in the airport is working. That means the when you enter the airport, right? If you look at the airport, in the beginning of the airport, you have a counter, right? You have a ticketing counter. Then you go through some kind of immigration, right? Then you go through some kind of uh, check. Check your pocket, check your clothes, you check your bags, and then you are able to coming into a bunch of waiting areas, right? A bunch of waiting areas that you have. Okay, so the person is now going through this user like was going through this path, right? Now this guy also have to go through this path and come around here and go around here, right? And then go around here, and now they're in the airport. Now there is bathroom, there is bunch of things, and there are a lot of gates. But this person can kind of move around, roam around here, kind of freely, right? That is what SE Linux does. When you see the word unconfined underscore U, okay, that means that the context given to this is the context. This is whole Linux is the context. This is your context. This, like a file, this user can go anywhere. They can move around. In fact, if there was even if they have a pass, that even if they came to the front desk, they say, hey, hello, Tayo, how are you? Goes to the immigration, hey man, how you doing? Oh, hey man, what's going on? And he goes into this area. This user is unconfined. They can go in and out of this whole system with a certain unconfined user permission. Okay, they were not confined. So what we are going to see is that this is unconfined user. This is the unconfined role. And this is the unconfined, we are going to look at domain and permissions. Okay. So right now we're looking at the first one, unconfined user. This user can move anywhere. But if you change the context from unconfined, if you change the context, unconfined underscore U, now becomes a user underscore R or user underscore admin. That means that this user can only stay up to this point. They can't go here. They can't go all of this around here. They can't go here. If you give them, if you confine them, right? If you confine them, then maybe this is all they can do is they can go up to the immigration desk and that's it. They cannot go past the immigration desk. SE Linux will not allow them past that desk. SE Linux will confine them. So SE Linux will put a barrier. So when this user tries to come in through here, let's say they try to come through here, SE Linux will stop them. Okay. So this person cannot go through this line. They are not permitted. They can go up to this point. That's about it. They cannot go to this. This space is unavailable. Anything beyond this point is not available to this user because they are no longer unconfined. They are actually now confined, meaning you have put them in a very limited space where they can operate. Why does SE Linux do that? We're going to talk about that because we're going to do a project, a website project, right? We don't want hackers to come and be unconfined, running all over the machine. They go, they enter inside here, they enter inside here, then they find a file. And once they get inside the file, that's what the hackers do. And from this file, or this machine, now they can SSH into that machine and they can access all the files. And now they can get into is from this file, they might be able to get to this machine, then they can get to this machine, and they start hacking the system, right? So SE Linux is a security enhanced Linux that says, first of all, we need to give a context to every user in the system. I don't care if it is root, and I don't care if it is any user. But if they're unconfined, you got a problem in the system. So, identity management question, ladies and gentlemen, I am your manager. And if I asked you, how do you check the identity uh, um, of the users, you will say, I'll run the ID command. And in ID command, I'm going to find four things. I'm going to find four things, right? I'm going to find four things. That ID is either unconfined in these four areas or that ID is confined to some user or something, right? So this is the first step in understanding identity, how Linux treats identity. It takes the ID, initially it's all unconfined. Great. You guys want to, did we start this? Yeah, we did start a recording, right? No problem, no problem, no problem. All good, all good. Anybody want to step out, do something, just watch the recordings, right? So now we have basically, let's clear this drawing. Let's go back to our notes. Now let's take this one step further, right? So what do we have here, right? What do we have here? We're seeing unconfined U, right? We're seeing unconfined U. So let us understand the four distinct components of identity command. SE Linux doesn't care about traditional Linux usernames or UIDs. SE Linux does not care. So this is the statement that you're going to tell the guy in the interview. You're going to tell me, what do you know about identity and access management? Well, when I type in the ID command, okay, I get four distinct components of identity. There are four distinct components of identity when I type in the ID command, other than just saying that UID 0 is root. So this is irrelevant to me, right? This is irrelevant. What's relevant is the context. So you tell them it's the identity context. So if you want to make it very simple, so do you know about IAM? Yes, I do. Tell me about IAM in Linux. Well, If you type in the ID command, you're going to receive right. Oh, perfect. Okay. Now I type in the ID command, and the ID command will give me the context. Okay. So SE Linux doesn't care about the traditional Linux usernames like UID. Okay. Instead, it reads this specific label to decide what a process is allowed to do. Right. So unconfined U, this is the user identity. Unconfined R, this is the role, the gateway between the user and the process. Enter into unconfined execution states. We're going to talk about this coming up, not today. Okay, unconfined T, type. Type when applied to a file, or domain when applied to a process. Very important uh, when we're talking about. Second, what is this? Okay, let me close it. One second. Okay. So if I run this ID, how I put the, that is how, when you run ID as a root, is actually the standard default behavior on most Linux distributions, Linux, RHEL, CentOS. So, so so these are the four things that we want to take a look at. Okay, what are they? Right. So let me. Okay. All right. So moving forward. Okay. We're looking at the, so by default, SE Linux operates under a targeted policy. That's what it is, right? It has a policy. What you're reading here is a policy. Context is really the SE Linux policy, right? So the philosophy is to strictly confine network-facing daemons and system services, right? While we are going to allow the regular user sessions relatively unconfined, right? So So unconfined -u user, which I have put up over here. How do you check details about SE Linux identity, right? You run that ID-Z, okay, and that's going to give you a context. Now, unconfined U, the user, the SE Linux user identity, it has nothing to do with the Linux UIDs, okay? If you do not enforce SE Linux, we are going to talk when we get to SE Linux. There are two ways you can enforce it, or you can set enforce, or you can lower down the enforcement. Right, the security in the airport can be very high, extremely high, and could be very minimal. Like, you know, really that very easy. User R is reserved specifically for restricted non-dominant. Okay, blah blah blah. Uh, Then unconfined, allowing standard Linux, we're going to talk about that. So basically, user is mapping to unconfined. The way all of you should check a system, it's saying that your Linux safety, your safety enhancements are not really in place 100%. Your system is vulnerable. Okay. Your machine is in a state. So if you are working at a company and you went to type in ls-z and they asked you in an interview, how do you make sure that, um, what would be one of the checks to ensure that the identity are user hardening has happened. ls-z. Okay. We'll look at these questions, interview question later on, but it starts to build up from now. Okay. Next. Next thing is that we will install this DNF. I'm going to pass it to you all in the, let me see if I can copy. Oh gosh, let me see. Let me see if I can install this. Let me pass you the link. There. Let me put it in the chat for all of you. Try this. Okay, chat. Where's the chat? Ifra Kausar, you had a question after break. Do you still have a question?
यस सर, अभी एक क्वेश्चन है कि ये जो अनकन्फाइंड हम देंगे फिर तो वो फिर सिर्फ रूट यूजर को देंगे.
Even you can even so the question is unconfined is only to the root user. No, unconfined. You can even confine the root user. Okay, even root user has to get confined sometimes. So I'll show you what it means. We हल्के हल्के इसको build कर रहे हैं. Very good question. How do we do unconfined? Right now, when you install this tool, DNF मैंने भी आपको भेजा है chat के अंदर. All of you can copy this tool, run it, because you need that command that's on the Red Hat exam. On the Red Hat exam, they're going to test you on how to use the cmanage command, right? SE. SE is SE Linux. So cmanage is SE Linux policy management tool. So if you want to manage the policy of SE Linux, the command you're going to run is semanage login-l. Okay. So if you guys don't have that, go ahead and use DNF install -y, and then it's going to run through and it's going to show you how your package has installed, right? It's going to install it. It's going to say it's complete, right? Okay. So step by step, we are doing this. Step by step, we want to understand this. So when we run the semanage command, cmanage, okay, SE stands for what? Security enhanced. Okay, it is the one giving the context of unconfined. ID-Z, ID-Z, capital Z or Z. Remember these two. You don't need to learn a lot of commands in SE Linux. But if the question is about identity, you must know the first one is ID. It gives you the context. ID-Z also gives you the context, right? It takes away all of this away and just gives you the SE context. Okay. So if you said in an interview ID-capital Z or capital Z, your answer is going to be right. If you said ID, your answer will still be right. Right? If somebody asks you what's the difference between ID and ID minus Z, nobody does that. But sometimes you have some smart people sitting, they would like to throw you off. Understand they're one and the same command. The flag is -Z. Now, security enhanced manage tool -L. Okay. Oh, what did we do? Login. Sorry. Login -L. My bad. Login -L. So when the login name, right? The login name is default. Okay. The login name is root. This default is all any users. Any users coming in the system that were created using the user add command. This is called mapping. This is the mapping. This is the mapping. Okay. This is the map. The word is mapping. So you'll hear a lot of times in IT industry mapping, right? Mapping. So you're mapping this. Mapping meaning what is your when you did user add, okay, you have a login and you have the root. Okay, you have all of that. Default is the users. Okay. Next, it says unconfined user, right? Root is also unconfined. And yes, you want the root to be mostly unconfined. But do you want all the users to be unconfined? Answer is no, right? So when they're unconfined, uh, what can they do? What is it they can do? Even though this is where it SE Linux is saying if they're unconfined, they can uh, RWX, RWX, RWX. These are the permissions on a file. Okay. Unconfined means that user student can come in here and they can modify certain file permissions. They can modify certain file permissions. But when you enforce this, then a user, no matter who they are, right, who they are, they cannot change the file permissions. But before we get too deep into this and to understand, let's not go into file permissions. Let's just stay with one thing for now. We are trying to build one concept at a time. If you get too much busy, it will become hard to understand otherwise. But it's very simple. Everybody understands unconfined. Everybody understands root is unconfined. If you understand that much, you're done doing very well. Now, what is this number that we were looking at? MLS, MCS. This is sensitivity. The compartments or the categories ranging from 0 to 1023, this is the processes that can be accessed. Okay. So what we're trying to say here, right, is let's come back up here a bit. 1 second. So number one, when we look at this mapping user, what is this? This is the user identity. Like I already said that to you. This is the user identity. SE Linux user, as we just saw in the cmanage, is not the same thing as a Linux OS user. SE Linux is mapping standard Linux accounts to its own internal identities. And by default, standard users and root are mapped to unconfined, right? So when we look at how SE Linux is managing, it is mapping these users and telling them that they're unconfined users. That's how SE Linux is enforcing this. Now, unconfined R, what is this? This is the role. SE Linux uses a role-based access control, meaning if I give you a role as a Linux admin or as a lead or as a developer, that's a role. And under that role, I can actually define how far I need to confine you. You're a developer, you cannot work in a production environment. I need to confine you. You can be unconfined, right? So unconfined role, R stands for role. So if I'm a guy who is working in uh, before the immigration, I'm working on wrapping the bags. My company provides a service for wrapping the bag. You bring your luggage. I take a little big polythene machine that just does it. But can I go inside? Am I confined or am I unconfined? I'm confined. I can't just go all over the airport. I'm only confined to the area where I can work. Okay. Even going into the airport, I have some kind of ID that limits me. So my role is I'll be working in baggage claim. My role is I'm working on ticketing counter, right? So the roles will tell you how to confine the process, what processes you can access, how to control your process so that there is no hacking of the system. Okay. So roles are acting like a gateway, like I put here, between the user and the process domain. So an unconfined user is assigned, like we said, the unconfined role. They have the authority to enter unconfined execution states. So the purpose of this, of a person with this kind of thing, is they can run all kind of processes. So if you want to limit the number of processes, you can limit the processes they can run, we'll have to confine them here. Then you have the type and the domain, right? Which is this one, type and domain, which is the most important part. The most, that's why I have this in yellow. Okay. Most important, right? So type enforcement is like the core of SE Linux. So I'm not going to restrict this process. So if I have this unconfined, if unconfined team, we're going to do a website. You have millions of users using websites. Use HTTP port 80, right? Right now, you guys are accessing media CMS, labs.nit.academy. You're coming right into the machine, right? So I'm not going to restrict this process, right? So standard Linux file permissions are handling the security. So if a daemon, for example, we have an Apache daemon, which we are going to do next week, we're going to run a daemon called Apache daemon. It would show the context file for it, httpd_t. Why? Because there is a path var, okay, www.html, and under HTML, you will have an index.html file. All of you are going to do that next week. You're going to open a file, you're going to download a static website, and it will have your website here, right? Now, this is all these files, this var folder is part of the Linux file system, right? And all of this is within a machine, right? And then you have ports, right? You have a port which allows the traffic to come in. Let's say you're coming into port 80, right? I have a firewall, okay, already is in place, okay? So I have a firewall that says, hold on a minute, do you want to allow port 80? And I will have to go and enable this firewall. I have to make this that, yeah, please go ahead and allow anybody coming through this port. And if that happens to be HTTP, if that protocol is coming through here, if the call coming from the World Wide Web, somebody is sitting here, they type in labs.practice.nit or lab.nit or guacamole.nit, whatever you type in here, right? So that information is coming over the internet. It's coming on through because it's a HTTP or HTTPS. It's taking a protocol. It's coming into the port. The port says, do you want to allow HTTP? And it says, yes, allow HTTP. The person that says yes and no, the filter that allows or does not allow is the firewall, right? Once you go past the firewall, right, there is a page. So this user now would have to go to this path. So it now takes a path, right? It comes over here and it finds the var folder, then it finds the www folder, then it finds the HTML folder, and it finds the index file. And then it takes this index file and it takes it all the way back into your machine to open it over here. Okay, it opens right here in front of you. So when you open labs, that's what's happening. You're going down through a path and coming here. Now, if we don't have SE Linux enforced, right, you're unconfined. What this is saying that your type and domain, okay, HTTP_T. We're going to play with this a lot. It's something we're going to use for testing a lot. HTTP, if you see _T, type, right? This is type. If HTTP from this point on is confined, it can go to the root directory here. It cannot go here. It's confined. It can only go to where the HTML folder is available. It won't be able to go to your home or to any other OPT or So it's able to go because you've defined that it is confined. I don't want this user to be all over my server checking out files and deleting files and who knows what else they can do. So I'm just going to confine this query. So every time this call is coming in, this call is confined only to this path, to this type. So that's why we are saying, let me close up. Now, let me all this, and if you look at that, okay. So unconfined, this is the type when applied to a file or domain, when applied to a process. So uh, type enforcement, like they say, which is the core of SE Linux, because this shell is running in this shell is running in the unconfined underscore T domain. Okay, so SE Linux essentially is saying, I'm not going to restrict this process. Let standard Linux file permissions handle the security. Uh, if a daemon like Apache were running, it would just show HTTP D-D, and it would only restrict it to the web server related files. That's all. Okay, so the type. And finally, you have the sensitivity. So SO is the sensitivity level, like low sensitivity, which means, and you don't need to worry about this too much. Root has access to full range, 0 to 1023. It can see and manage all the container sandbox. We don't need to worry about that. This is the one we are going to worry about the most in identity management. Okay. So now this is an important thing that we need to look at. Once we do the user practice lab, this is the one, right? So there are Linux security is managing in 3 ways. Remember that. This is all you need to know. So when they ask you the question about identity and access management, you will say the identity is when I type the ID space -Z or -Z, right? It will give me the SE Linux context. That is the answer. You got the job. That's the answer. It will give me the SE Linux context. Nobody's going to ask you, oh, what is the user context and what is the type context and what is the SO to 1023. That is for you to understand. If somebody digs it deep, you can respond. At least you're aware that there are 4 components. Okay. There is a user component you want to confine. You want a type like HTTP services coming in. You want to limit hackers to come and just access certain path, certain folders, not everything in your system, right? So Linux security is sitting under 3 names: DAC, MAC, and RBAC. Okay, DAC is a discretionary access control. We're going to learn them tomorrow. We're going to go into details when you talk about things like, you can see this cartoon says owner controls the access. You see the young kid sitting on the desk, and that is the root, and different users are coming in and say, okay, go ahead and you can have access. My files, ACL. So if you see here, I'm saying clearly, I'm saying one thing to all of you. Owner controls access. The user holds the keys. The user holds the keys, right? You can't forget that. That's somebody asked you in an interview, what is discretionary access? The user holds the keys. In this picture, you have a user holding the keys. Okay. So you're young and you're playing with cartoons and they ask you to match the two pictures, I'm sure you know what that means. So you can identify what this picture is saying, that the user is holding the keys, right? Flexible, but it is risky, right? It is risky. So there is a discretionary access control. I decide who can open, edit, or run my files. Okay, some discretion. You are the lead. You are the guy working in. You have your own files. You have your own home. You have discretion on your files. You can create, but there's still some control. Owner is controlling the access, right? Um, in the mandatory access control, the system is enforcing the access, which is what we have talked about. System, right? Which is Mac. The system holds the rules, right? The system. Here you're holding the keys, which is what we're going to study. Line, is file permissions and things of that nature. And then you have the mandatory access control. And then you have another one, which is over here, which I haven't put in any cartoon, is your role-based, right? Access control, RBAC. But these two pictures are very critical for us to understand. Okay, so a user comes in, they can't just go and the policy, manage. When you hear the word policy, memorize manage and policy. Red Hat exam is testing you on this. Okay, manage. How can you manage? What tool do you have for managing Linux security at a very OS level, right? So Linux OS security policy, right? Access denied, your label doesn't match the policy, right? Look at this robot. You have somebody coming in saying, I want to be able to access this lock over here. And the robot says, access denied. Your label, you are not unconfined. You are confined. So let's look at your label. If the label have a hyphen T context, maybe you can only go up to this path. If you have a different label, we cannot allow you to go here. So this is mandatory access control. You can enforce on the whole system, or you can remove it. A lot of times you're going to learn, oh, my application has been downloaded, but it's not working. And the documentation will say, check your SE Linux, try to remove the enforcement, then run the application, then apply the enforcement back again. Okay, now you will understand why. Because you have the overall airport security system. If you bring down the entire airport security system, all the doors and gates and everything will open up, and you can potentially damage the airport, right? So that's why we have to understand these two things. That, okay, let's keep on going. Let me see if I can remove this. Right. So now let's go to the simple part. Okay, this is laying the bricks. This is laying the foundation. I'm going to take you away from SE Linux because our class is not on SE Linux, but we need SE Linux to understand what SE Linux actually does. It is managing. SE Linux is a policy management tool, right? So if you don't like to have the policy, you don't have to enforce it. Like right now, this is all unconfined. Okay, so let's go. So user management. Let's talk about user management real quick. Every time you do a user add command, what is happening, guys? Every time you do a user management, it gives you a UID, right? You have to give a username. You can give a password. Where are these names stored? Where are these passwords stored? Users are assigned a home directory. Users are assigned a shell. Users can read, write, and execute. And this, my dear friends, are called permissions. And these permissions are DAC, discretionary access. Okay, these are permissions. Okay, so let's look at it in a good way. Every file on the system is owned by user and associated with a group. Fine. So let's go a bit forward. So you can have a group called Linux team. and you can have a group called developers, and you can have somebody that could be working in two different groups over here called DevOps. You can have three people. This Yasin is in developers team. Maria is in Linux team. And then we have all three of them working in a different group. So you could belong to a group 1, a group 2, and a group 3. So, but when you create a user, you get a primary group, right? And you also can get a secondary group. So this people here, John, Maria has a primary group called Linux team and a secondary group called DevOps. So she has a primary group called team, Linux team, and Maria has a group that is DevOps. Okay, so that's simply stuff to think about. So user add Tom, and then what do you see? Let's go through this. Okay, let's go through this. Okay, so let us see how many users we have. Let us do a user add to this Tom. Okay, if I wanted to give him Tom a password, I can. Okay, before we give him a password, let's look at the files. Let us look at the files. And what are those files? Okay, so the first file we're going to go into is cd. We can just cat into the file, etc, and we have password. There you go. You can see clearly here that Tom has been added. Okay, and you will see there's other users sitting in here too, right? And you see there are users called no login users. Not we studied non. Remember, do not forget that there's a big difference between what do you call this thing? No and non. Non-login shell. We talked about this in early on. We didn't talk about the no login shell. This is a different animal. We're talking about the non-login shell. Okay. So when we talk about applications, we will talk about all these no login shells. What are they? Why are they? So don't worry about that right now. All we are trying to look at is Tom. Okay. Look at Tom. Let's see if we can. It's been a while. I haven't done this command. Let's see. Tail -n 5. Okay, let's do. Okay. So
Excuse me, boss.
Yes.
You already clear? I want to ask you to scroll back up. It's okay.
No. Oh, you wanted to take a picture of that?
That's correct. Yeah.
We are going there. We are going there. Don't worry.
Okay.
Yeah. Don't worry. I before I delete a picture, I'll let you know. You can take it on your camera, and that's fine.
Yeah. Thank
So you're welcome. You're welcome. Let me find this again. Okay. Delete, clear all. We are coming back. We're going to go back to the whole discussion. Okay. So, what do we have here? If I just type in the cat etc password, I'll see the whole thing, right? Now, what if I just want to see the last 5? See, in this one, we have a long record, but I don't want to see the whole record, right? I just want to see maybe this, or maybe I just want to see the last 5 lines. Okay, that's all I want to see. Maybe I want to see just this line only, or the last 5 lines. So Linux allows us what is known as a file operation, right? So I can go here. I can go grep. I can go grep for Tom. Like grab, no B, but P, like Paul. Grab Tom from this file. etc password. And it is going to grab that one piece of information that's in that file. It's gone into this file, and you say grep. grab for me anything that has to do with Tom, give it to me out here. So that's the one line that you're seeing with grep. You can also do tail -n 1 etc. If I do tail -n 5 records etc. password. Now I can see that 1, 2, 3, 4, 5. 5 records from below. How about from the top? I can do head -n 5 records from the top. Now I can see everything from the top, right? I can see everything from the top. I can see everything from the bottom. So let's say this file is very big. So I just need to see head. So tail -n. N is the numerical value of how many records you want to see. Let's say I want to see 3 from the top. And I want to see, sorry, I want to see 3 from the top. N, sorry. -n3 etc. And I want to see 3 from the bottom. So I can see from the bottom 3 records, from the top I can see 3 records. Because in Linux, sometimes you open a file, it is so huge, right? For example, we said cat etc login defs, very long file. But if I wanted to just say, if I wanted to say a tail, number of records, let's say I just wanted to see 10 records on the bottom on etc login.defs, it'll show me just the 10 records. 1, 2, 3, 4, 5, 6, 7, 8, 9. Apparently there's one blank space here, 10. There's a blank space here, 10. So it's showing me 10 records. And I could simply modify this and see 30 records, right? So what are the from the below up 30 records? So tail and head commands can help you see a lot of things. So that's done. So let's clear. I want to go ahead and grab Tom's information from etc password. Sorry. So there is Tom, right? There is an X over here, right? His ID is 1003. His group is ID is 1003, right? He is located in the home. There is a gap in between here between the two. Let's see here. I'll come back to it real quick. So we have Tom, right? Then we have his password. This is another file. We're going to look at that file called this is in the shadow file. Shadow. So we have to go to the shadow file to see if he has a password or not, right? This is the user ID. This is group ID. This was if he had put some comments, but there are no comments here. Then you have the user's home directory, right? That's where all his or hers files are. And then the shell, where they're working, the notepad, pin bash. So this is the 7 different things that you can see when we did user add. When we did user add, this is what was created. and it's something you can locate in etc password. Now, let's keep on going. Let's keep on going so that we can finish our material. So now you can see here, ladies and gentlemen, when we do user add Tom, there is a folder called etc password. Inside that etc password, you have Tom and X. This is the shadow file. Okay, UID, GID. You already know where to get the UID, GID. UID, GID is a very easy to get. UID Tom, sorry, ID Tom will give you his UID and GID, right? Just the Tom. We're not looking for the context. If I want to know Tom's context, I'll just to look at that he's unconfined because everybody coming in is unconfined. C manage login -L. C manage login -L. So I can see that when Tom was created, he's part of the default, he's part of this. So you kind of start getting a feel for Tom. You want to see, hey, where's Tom? What can Tom do in our system? We created Tom rather than just saying, oh, user add. Now let's find out more about Tom. Does Tom have a password? Everybody. Did I give Tom a password when we added him? No.
No, we have
No.
not given him password. Yes.
Right. We have not given him password. And we are saying that if you do a grab, if you grab for Tom's information and get it from this etc password, there is an X. Let's examine that file. Let us go to that file. Cat etc shadow. Aha. When you open this file, you're going to find out that Tom is there. There is some information here. Don't worry about it. But there are two exclamation marks. Two exclamation marks, which means that his password, he has not been given a password. Let's give him a password now. Password. When you remember we were creating user, then we say password. Okay, now let us see what happens when you give somebody a password. This is the shadow file. The shadow file is going to get changed. So password for Tom, hit enter, says okay, ABC, ABC. Okay, let's see what happened next. Now, do I need to do this? Because I'm going to go all the way down, or can I simply do Control A and do grab? I can grab for Tom, or I can use another command called tail, and I can look for the record at the tail, because when I opened this file, I saw that Tom is at the bottom. So I can use this one for now. Tail, look at the bottom of the document, go to the bottom of this document. When you open this document, you're telling Linux, इसको खोलें, इसके end में चले जाएं. Open it, go to the end of it. Tail. And then from the tail, count up. Number of record. Give me the first one. Okay, very easy. But we can use both of them. Grab, Tom, easy. Now look at the difference. You had Tom with nothing, and now suddenly has Tom with all of this encryption. A password has now been given. That's how you know that Tom has a password, and if Tom doesn't have a password. That's how the password command does. Password Tom XYZ. XYZ. Let's grab again. And this time around, you can see that this started with $VS, $DA. I changed it to XYZ. You can see it has a totally different encryption, totally different token, totally different information, right? So when we create a user and do password, it's in the shadow file. And the information about the user is in the password file. So password info is not found in etc password anymore. It is in etc shadow. Why? Because Linux wanted to keep it clean. Why clean? Because if I do grep tom etc password and I do grep tom etc shadow. The reason they put the X is because X equals to this. Imagine if they had to replace this X with all of this information, you put it inside the X, then this thing will look so funny. It will look more like this. Let me show you. It's going to look like this. You will basically replace the X. This is how it would look like. This is how it would have been looking like. And it would be so difficult for somebody to know, oh, what is this and what is this? So by putting the X over there under the password, so there's no password there. So don't get confused when you see etc password. Remember, it is just Tom's information as a user ID, group ID, his home directory, and the shell. But the shadow file is where you have this whole information. If you replace the X with this information, you're going to have something so ugly looking, so hard to understand. So Linux has made this easy for all the users now. Okay, Control C, Control C. Okay, now let's go back here and let's keep on moving. We have time. Okay, so etc shadow, you put in the password. Okay, and then let's check. So there's a check you can do called a password check. Which goes into, we know that the password is X. It will go into password and it will say X, and X is actually shadow. etc shadow is the same thing as the X that you see in there. So when it goes to check it in the password, it looks at the X. X, it'll tell him, okay, if you really want to know what is X, go to etc shadow. Okay, I hope you're very clear. So when the system comes in looking for this file, etc password, and then you have Tom, right? And under Tom you have X. When it comes to this X, it goes to this file immediately and checks what's in this file for X. So this is X equal to shadow. X equals to the etc shadow. Just remember that. They did this for ease and simplicity. So yes, you can tell anybody in the interview, where do you check the password? etc password. But when you go to etc password, there's a X. X means the Linux has to go to etc shadow where the password is found. Are we clear, everybody?
Yes.
Are we clear? Any questions at this time? कोई सवालात तो नहीं है?
No.
Okay,
So
very
far, so
clear
good,
now.
sir.
What's
What?
your last command? PWCK.
Oh, we're gonna do it. We're gonna do it. Let's do it. We're gonna do it. Are you guys following? Are you enjoying it? Right? I hope you guys can making sense of what we're doing. PWCK. Okay. Thank you. Okay. PWCK. Okay. What happened here? I did the PWCK. I haven't run this command in freaking maybe 5 years. Password check command. We are basically gonna go. Okay. Password entry was okay. Okay, I gotta look at the PWCK. Okay, so if you run Peter, I have to look at my notes. Okay, if it's been a while. So if you run PWCK, because you're gonna do 2 more checks, it will check in the etc shadow. Okay, it'll check in the etc shadow. So what it'll do is, if you do PWCK, if there is, for example, a user add, let's say we add, let's look at the users. Let's test it out. Okay. Hold on. Okay. We have LL. So let's add a new user. User. Okay. We have Tom here already. Okay. So let's clear that. User add lab user. Enter. Lab user is added. So how do we confirm that user was created successfully in the 2 databases? Okay. How do we know they have been created as a database? So those files, password files, are your database, really. Okay. So if I do tail -1, okay, etc password. Let's look at the password. If I added the user, add label, how do we make sure that the user was created? I have to go to the password file, and it's going to tell me the user is created, lab user is created, right? Now let us go to to tail. We can just use the up arrow and remove the password and put shadow. Okay. Now you will see lab user sitting happily. We can see lab user here. We can see lab user here, right? So let's open the password file. So let's open the password file. Let's see shadow. So let's say that we wanted to user delete. Okay. We said if you do user delete -R or without that of lab user, this is a clean way to remove a user. We all understand that. But let's say that you're not having a good day. You're not having a good day, right? You ran the PWCK after removing user and you're having a hard time cleaning it up. Okay. So we open the password file. Okay. Let's open the password file. It's throwing a lot of warnings. Okay. It's throwing a lot of warnings. It doesn't want you to open the password file. But we had some genius in the company who decided to go ahead and open the password file. Okay. And you can see the lab user at the bottom of it, right? So let's just go down. And some genius came down here and did DD, and removed the lab user. Okay. Escape, it up. We're going to write the change, quit, and force. Aha. So if I now try the tail -N1, okay, there's Tom, but I don't have the lab user. Okay. So some genius goes into the password file and decided to change it. Or let's not even say that. Let's say that by mistake that a file was tampered or corrupted. Okay. That's actually the right use case, because most system admins will not go into the password file and change anything. They will use the user delete function, user del, to make sure everything is removed clean. But let's say that something happened, an outage happened. You were trying to do user delete, outage happened, machine died. You're not sure if your user delete command went through. Maybe it did, maybe it didn't. And suddenly the file got corrupted. Maybe the lab user was deleted, all the functions did not happen. So you got a problem now, right? So now technically what we have just done is what have we done technically? Because we are all here trying to be techs. So technically we have corrupted the etc shadow file. We have simulated a corruption. And this can happen, like I said, could be many reasons. You're sitting and scratching your head, user delete, didn't go away, user delete, okay, user delete Tom. Tom is still there. What's going on? Password check is showing that. So let's go through this motion. So how do we catch the error? PWCK. Watch. Watch. Before, there's a no matching password file entry in etc shadow. Okay. Now run the check tool, which we have, right? So it's going to scan everything, right? Add user
Nadim,
root in
this PWCK actually check all the user password.
everybody.
Okay.
Okay. So let's see. Let's look at tail, head. Any changes to the file. Password check is you're checking, it's a check of the file, whatever is inside that file. Okay. So if I go ahead, -n, I think 3, etc, password. So the root user is there, right? We didn't change the password. So PWCK, right? PWCK. Hold on a second. Okay. One second. There's an orphan. Okay. So now this is a very important one. Do I type yes on this one? Do I
Yes.
type yes?
Yes.
Okay.
Why are we
Anybody?
gonna add
You already
root
have
here?
root user, then why
There you
adding one?
go.
Root.
There you go. There you go. You have to be very, very careful because you did the check. You can stop it before you type yes or no in Linux. Remember your best friend, your lover, okay, is Control C. Control C, Control C, Control C, Control C. Stop. Stop, stop, stop. You got to investigate what this question is. Just because Linux is asking you a question doesn't mean you have to say yes. You can also say no. And so you have to go into head. Let's look at the cat etc password. Well, I can see root over there. Root is right up there. Okay, do I have a password for root? Let's check the shadow file. I do have some password. Nice and dandy. Now, if I run PWCK, do I type yes? No. I type N. N. No. Okay. What this is telling us is there is some problem between the shadow file, some problem. It hasn't been able to find out the problem yet, but it's saying that possibly there's an issue between your shadow file and your password file. You have a password file and maybe something, a lab user was added. but it hasn't found the lab user yet. Okay, but it's basically saying that Etsy Shadow has some problem. So I'll say no. Please do not type yes. You're going to corrupt the entire file. But even if you do corrupt the entire file, if you did yes, which I'm not going to do, but let's say you did yes for any reason, and the file is corrupted, there is a file by default in your cat. Let's go to CD, Etsy, and let's look at LS. In the Etsy folder, ladies and gentlemen, we have a file called a shadow file group. Let's go to shadow. Where's our password? PQ password. We have password and we have password hyphen. We have shadow. Where is shadow? RS. S.
SH. We don't
Where
have
is it?
shadow. No shadows.
Group. We have group hyphen. We have
Scroll down करें नीचे.
we have shadow. What is the minus for here? It means it's a backup. These are the only three files in the entire system. The password, the shadow, the group. The group shadow files, right? You see any other file in the system, there's no minus. This one has, anyway, this has got a backup. Shadow has a backup. Okay, password has a backup. These are backups. It knows that if you make a mistake, remember we said we can restore the mistake. Okay, let's take a look at it. I don't want to destroy user. I won't do it in this file. I'll do it in the lab. Okay. Because
Sir, maybe the problem is that you are in home directory, not the root home.
no, I'm in the root. I'm root user is using the root prompt. So user can
Okay.
the shadow. Let's look at the cat shadow. Okay. Cat. Where's the shadow file? Shadow. Okay. So if I go VI, right. So the VI file under shadow has this old thing showing. It has taken a backup of that. So if we run into some problems with shadow, I can recover it from here. So hold on. When we do patching and recovery and all that, we'll talk about that. We don't want to, unfortunately, we don't want to disturb this user whose machine I'm using. Okay, next. So we saw that the user root exists. User root has a password. Okay, so all right. Okay. Let's see. Hold on. Let me see. I'm looking at my notes. Wait a second. User. Okay. Let's see. PWCK. Okay. 1 second. I just need to check something really quick. User for. One second, guys. 1 second. I just want to see this. problem is because someone or accidentally created an entry for a user named G instead of root inside Etsy shadow. So, okay, let's see that. Hold on. See, I didn't want to touch this, but now we have touched it. I may have made a mistake. So look at, let's 1 second. Cat Etsy shadow. Okay, let's just do tail. Sorry, let's grab root and Etsy password. Grab root Etsy shadow. It has removed the root's password from here. So let's go password root ABC, and we say grab root. Let's see, shadow. Now we are back. Okay, we are back, and let's do PWCK. Now we have it right. Now we are right. You see, when I opened the file by accident, I didn't realize this. By accident, that's why you don't want to, I was telling you, some smart guy opens a file, and by mistake, I did something on the first line. I made a mistake on the first line. Okay. Then I came down and I did the delete. So what happened initially was that, what did I do wrong, guys? What I did was I went to the Etsy shadow, right? I opened it. Okay. And when I opened this file, okay, coming down here, now we've added root. Okay. Up here, if you see there, it says Goot. Look at that. You see that Goot? There's no such thing as Goot. I had mistakenly replaced the Goot with, so I added something that's not right. So if I do here, delete that. Before I delete that, let me get out of here, quit, and then come back again and make sure that, yeah. So DD, delete, okay, and X. Okay. Now, if I can still let's I don't want to exit this guy's machine now that I've managed to change a few things. What I like to do here is, let me see, VI, let's do password check. Okay, good. So root is fine. We have reinstated root's password. Okay, see, these are the things that can go wrong on a night. Now, you have to have your head open, your mind, and you have to read the lines. Okay, I made a mistake, and you can make a mistake in a billion-dollar company, right? Here I'm teaching the class. By accident, I went and changed R to G, became Goot. And then when I did the password check, it didn't pick this check. It first went to root and said, first line it was reading was GOOT, and said, look, there's a problem. Change it. Now, can I delete it? Yes, I can. Why? Because I'm still root. And if I delete my password and I create a new password, I'll be fine. Now it says that you have to add this user in the Etsy shadow. Password check is showing that we have to add this user in Etsy shadow, right? Now, do you want to say yes or no? Now tell me if I should say yes or no. Bataye. Yes. Sahid says yes. Anybody want to say no? I'll say yes. Now you run the check. Your check is showing everything is clear.
now.
Okay. Now you know the check is working fine. Okay. So that was the PWCK check. We'll do a lab on this. Don't worry. I have a lab on this for you guys. Now let's keep on going. Let's keep on going. We're at 1 o'clock. We'll try to wrap this up. And I've already posted this. Let's go down. So what are some of the things we need to check? Okay, next. Um, Adding a new user. We have gone through all of this. User add. Why did I say TJ3211? Because in companies, you don't have any Tom, you don't have any Alice, you don't have any Nadeem. You have different IDs that are given to different employees. TJ, X. Every company has their own scheme. Maybe you're part of the test team. You'll be your everything will be with T. Maybe you're working with the Jenkins. You're TJ. You're working in you're a tester working in the Jenkins team. So you'll be TJ. Maybe you are a QA. So your password may be tester Q, TQ, 3211, which means you're a tester working in the QA department with your ID 321. We know what, you know, how many users we can have? 60,000, right? Or even more. The login.defs file tells us. So when we hit the user add, we start to look at things that are happening in the system. We just did some little test to show you that the password file gets updated. Now that is wrong. That is wrong. There's no O. There's no R. So I'll have to push this again. I'm sorry about that. That's a big mistake. Don't make that mistake. Okay. So you have @C password, @C shadow where the password resides. We have a group that is created, the group of Tom. Let's quickly look at the group of Tom. So if you want to look at ID Tom, GID is 1003, right? Now, if I wanted to look at grab, so here, grab Tom @C password, grab Tom @C shadow, grab Tom @C. This is how you need to practice. How you need to practice. Exactly the way I'm showing you. You guys are working for me. I'm your trainer, and I'm bringing you on board in our company, right? So grab Tom @C password, @C shadow, @C group. So now you can see if you're an ID Tom that Tom has uh, Tom has a UID of 1003 Tom. Group ID of 1003, group ID is 1003. Tom belongs to the groups called 1003. So what does anybody understand what groups mean? Can anybody open your mic and just help me understand quickly? What do you mean by Tom is these are defaults. 1003, 1003. So if you come here and you add a group add SRC or QA, let's say QA. Okay, you've added a group called QA, or you've created called dev. Okay, you've added the group dev, right? Tom is already part of 1003, which is literally just a no group. It's just 1003, 1003. Okay. It is just following and matching the def file. If you go to the login.defs file, it says pick the next number, give it to Tom. If nobody has defined his UID, nobody said which group he belongs to, the default is 1003, 1003. Now, next guy comes along. If the admin does not say who this person belongs to, give him the default next number, 1004. Similarly, 1004. So now we have added a group called group add dev, right? So we can check the groups. We have group. There's a command for that. Okay, let's come to that. So now we have group. We have looked at there's another file called default user add. I want you to take a look at. Okay. We are not at the group yet. So now default. Default? Guess what? So this is one of the files when you do user add. When you do user add, it does this, does this, does this. It also comes into the user add default file. Okay, it goes to the login, it goes to the Etsy scale. So these are all those files that it's going to look at. It tells you the shell, it tells you the scale where you're going to get your skeletal. See right here to the Etsy scale. What is Etsy scale, guys? Anybody can tell me what's inside the Etsy scale? Anybody?
The file when we create an user and then some default file come to the user profile.
Initialization files,
Yes, sir.
environmental files.
Yes, sir.
Very good. Thank you. Get. Thank you. Thank you. Thank you for trying. Very great. Very good. Etsy scale. I think scale is two L's. Yeah, Etsy scale. Get. Etsy. Where am I? Oh, sorry. CD Etsy. Scales. Scale. It's a directory. Hold on. So CD scale. Okay. CD scale. Okay. So currently these scale files, why am I seeing total 0? Because it is ls-al. Now you can see the files. So if you ever open a file and you see a total 0, don't use ls-l. Make sure you put al. So a lot of people, they have the habit of admins using s-le or ali. You will never go wrong. If you remove ls-l, al. So it gives you all the files, including the hidden files. So scalp files are all the initialization files. So let's clear that. So now you know exactly what is going on the screen. You are all very familiar with all these, each one of these. We have played with them a bit. We're going to play with the group. We have another 13 minutes. Urdu class is not going to happen until Monday. So all the Urdu students don't need to worry, English students. We're going to go on. We have 15 minutes that will end it. So I have some practice here. We don't need to worry about this. User add Zavar. We change the password. The step 1, create a user. Step 2, create a password, right? So the user add command does the following, right? Add entries in your user management files. So password, group, shadow, okay, and GS shadow, right? Then it creates your default user added, the one we saw. And it creates a home directory. I've just talked about all of this. Now, when you look at that line, when we say grab Zavar, excuse me, let me give me some water here. So these are flags. -C is comment. -B is for the base directory. -S is for the shell. Easy to remember, the flags. And -G is the group. Okay. When you see Zavar is equal, when you type in grab Etsy group, Zavar, this is -primary group by default is -G. Okay, now we go to Etsy password, it's going to tell us the default login, know your shell, that we already know this. Now, the options that we have to explore, right? So, the most common one, I'm going to give it to you, are these two in the middle, okay? These two in the hyphen small g, hyphen capital G. So, if you add a user, -G, in an interview, they'll ask you, how do we add a user to a group, right? How do we add a user to a group? Now, -U, we have done it already. Very straightforward. Okay. If you see this here in front of you, This is the line. Okay. If you're going to add him to a primary group or you're going to add him to a secondary group. Okay. 1 second. Excuse me. So first of all, let me see if I can use, there was another command I used to use all the time. Can't remember. Other than, okay. Two commands. Number one, if I can go and look at cat @C groups, sorry, group. Okay. This is telling me all the groups I have. I created a group called dev. Every time a user was created, they were given Tom, this, that. So companies trying to limit this. We'll have a little end project through the week where when you create somebody, you create them just using these flags. So you never have to worry about determining where to put them. So if I just take the user, let's look at groups. Okay, hold on. So this is the command I was looking for. Groups, lab user. Groups, Tom. Groups, root. Groups. I don't know who else did we have in the group. Okay, fine. So if you just type in the groups and the user will tell you what group they are. They're just the user is lab user, the group is lab user. Root is in root. Okay, but now we want to change the lab user. So you're going to do user modification. You're going to modify the user settings. Let's change the settings. User mod, very easy. Can't forget it. User modifications. User mod, okay, let's create a few more groups. So what groups do we have? What groups do we have? Simple and short. We have currently
Dev.
dev. Okay. So group add QA. Group add prod. Group add SRC. Group add, excuse me, UAT. Okay, these are all the environments we are going to learn. Okay, now I can check and see, let me just say tail, number of records on the tail, let's say 6 @C group. Aha. So I have the lab user initially, then I have dev. Now, I would like to give, so there are two types of groups a user can have. We had one slide. I want you to understand this now because you guys will go and review the slides, and each slide I have put it for a reason, right? And you may miss this point. So let me come here and show you the point that I don't want you to miss is this point. Okay. Okay. So groups, guys, primary group, all users are part of one primary group, which is what? Lab user. Then the group you have given is the name of your own name. Okay. Your own name. Okay. And secondary group, you can have up to you can have this individual Tayo who's in the middle, or Akim, or Ifra, or Mubarak, or Aurangzeb, Isaac, Ibrahim. Any of you can belong to the Linux team. Or you can have a secondary group, up to 15 secondary groups. So you could be part of, so let's put it out here. You could be part of the dev team. You could be part of the QA team. You can be part of the prod team. You can be part of the SRC team. Well, let's say that currently you're part of the QA team. Okay. So if I want to modify modify. Right now, you're just lab user. Your group, lab user is your group. How do I know that? If I go to CD, okay, into home and look at my users, and I look at lab user, and I say, okay, CD lab user, and I create a file here called, you know, uh, we can say, okay, perf file. So lab user has created a performance file where he took all the performance data, how the CPU is functioning. He has dumped the output. He has put them in a file called perf file, performance file. Okay. So he has created a file called performance file, lab user, right? So if I want to do ls-l on perf.txt, uh, oh, it's a directory, direct touch. Oh, sorry. There we go. I can just do, okay. Two things I want you to understand. One, it will give me here. Two, if you have like 20 files, let's say lab user has created 25 files. Let's say that Mubarak has created 20 files, or John has created 20 files. He's not going to do ls-l because your screen is going to fill up with 20 files because you are the user, you know which file you're looking for. Maybe you created a file called perf.txt. So you don't do ls-l and hit enter because you'll get to, let's see, for example, let's create a touch file. Very, and let's remove the rm-rf. Okay, let's create another, let's do this. Touch. We're gonna create we can create okay. You have so many files. My idea that I'm trying to show you here is that you've got 100 some files. Do I always run ls-l? I don't need to run ls-l because my file may be perf28. My file may be perf20, but I can't even see perf20. Let's say I have this screen in front of me and I do ls-l and mine is perf, maybe my perf2. So now I have to go up and look, oh, where's perf2? Oh, where is perf2? Did I miss it? Perf, oh, so no need to do all of that. ls-l perf2. And it'll tell me anything and everything I need to know about that file. So remember that when we are teaching in this classroom environment, ls-l is good because you only have a few files. In real environment, ls-l and the file name is something you should become habitual in using. 20, then it'll tell me, oh, that's the listing of perf20. What is it? Okay, root. Okay. Now we are going to learn this tomorrow that even though the lab user has created these files, the root has created these files in the lab user. But if we go su lab user, okay, and the lab user now says, okay, I'm going to go ahead and touch lab files, okay, lab, some files called 1 to, let's say 5, okay, and he does ll, okay, and well, I don't see those files. ls hyphen l lab, lab 1. Now watch. The user is lab user. He created or she created the file lab ls hyphen l lab 1. Their group is lab user. The user ID is lab user. Group ID is lab user. When they exit, when they look at ls hyphen l perf 1, or let's say perf 10, the user ID is root, group ID is root. Why? What is the difference between these two? Anybody will tell me. The reason why this is lab user and lab user is because the user is currently lab user. So every file he's creating is, but when this lab user exits and becomes root, then all the permissions put on this file are roots. But we are not in file permissions yet. Let's clear this up. So now, what were we trying to say? We want to go ahead and modify user mod, okay? We're going to user mod -g -g. You can do it this way. Or -g. So what are our user groups? Let's look at our user groups first. Let's tail hyphen n 7 at c group. Now I want to change this is groups. Lab user is a group, but I want the user group. I want to have assign him user mod. Okay, user mod hyphen primary group. Okay, now look at this. What is the primary group? This chart is going to walk you through so easy. This is, you can combine them both, right? But or you can go -g, right? So you can say -g QA. Primary group is going to be QA, but the QA guy is going to work with SRC as well. -G will be SRC. And who's the user? Tom. Okay. So you're modifying a user. Now you can make it even much nicer. You can say user mod who? Who should I modify? Tom. What do you want to modify? Primary group. What primary group do you want to give him? QA. What else do you want to modify? You want to give him a secondary group? Well, no. Let's leave it in primary group. Okay. Now let's take a look at groups. Tom. Tom is part of the QA group. But now we say, okay, user mod. Who are we modifying Tom? Let's give him a secondary group. SRC. Let's check groups of Tom again. Tom is part of QA. Tom is part of SRC. Okay. Now, let's look at CD home Tom. No, sorry. CD lab user. Okay. Let's look at ls hyphen l, and let us see. He had created lab 1. What was in lab 1? It's still showing lab user. Okay. Because that's the file he created before. But if now Tom signs in as lab user, and he goes to and he creates a file called app.jsx. Okay. And now he does ls-l of app.jsx. Still showing him as lab user, even though he's part of the group. Okay. I see. What could that be the reason why? Even though he's part of the lab user group.
You changed the group of Tom, not lab user.
Right. So we have to do something here to modify. Wait a minute. So um
I think you're supposed to check for Tom, not lab user, because you
oh
have
I
not changed lab user.
oh yeah. Oh my God. You know what? Let's clear this. Thank you, thank you, thank you. We are going to do user mod. Who do we want to modify? Lab user. And let's give him -G um dev. Okay, well I'm not root. User mod. It's not Tom, it is lab user, and he's going to have a primary group called um, QA. And user mod lab user will have a secondary group called SRC. Done. Now we can go and see um, uh, his group and permissions. Okay, so we can go into ls-l, which is going to be home of lab user, and there's a file called lab1. There we go. There we go. User ID. If I look at the ID of lab user now, right? There's his groups QA, and he has got a secondary group called SRC. Okay. GID is now QA. User is, so you can see the ID has changed. So uh, that's basically thank you for that correction, and I appreciate that very much. Um, I'm using okay. So we have done today. We're gonna close this class. We have looked at password. Okay. We have another thing in password. We're gonna look at this is actually it's the account is locked because we didn't give them a password. You see the two exclamation marks. We did the password check to make sure everything is okay. You can even lock a user and unlock a user, right? You can do user mod -L and user mod -U, unlock and lock a user. Okay. We'll do a few exercises and how we know a user is unlocked. The reason it's unlocked is, let's say that a contractor comes to the end of the month. Their their contract is going to be renewed. The manager has confirmed that they should have started, but there was some issue within HR. They're waiting for the contract. Now they have to wait 1 or 2 weeks. So you're not going to delete the user. You're not going to remove his files. The user is coming back in a couple of weeks. So you just want to lock their account. This is where lock and unlock comes into play. Okay. You will lock their account by running a command simply as user mod -L, which is Ramsha. We can do that real quick and check it out. So let's say the Tom user mod -L, we're going to do this to Tom. Okay. So now that user mod -L Tom is logged, we can check, uh, we can check, we can grab Tom at C shadow, right? And you can see that the exclamation mark here says the Tom is locked. And if we unlock user mod -U, and we do that to Tom, and we run this command again, grep shadow, and you can see the exclamation mark is gone. Lock, unlock, lock, unlock. So
Lock
that,
means that he cannot do anything in his account, make or
yes,
any change. Yes.
accidentally, because maybe he's not getting paid, he's not supposed to come in the company, contract is not renewed. He will get his contract, but there was some problem. It happens to a lot of people. They were supposed to get a new contract. It got delayed. They're waiting with the manager says, okay, just can you wait for a week or two? Let me work this out. Let me get you back in. We don't have all the money to pay you. It's not like they don't. It's just maybe financially the company, the contractually there was some issue contract had to be renewed with their third party. So now maybe it takes 2 weeks to get the person back or 3 weeks. Sometimes Bank of America, what they do is उनके पास एक cool down period होता है. They have a cool down period, which I went through. 3 months, you're working for 2 years. They don't want you to work. They want you to go in a cool down period. You sit on the bench for 3 months. Okay. And then after 3 months, you're coming back. In that 3 months, they just lock your account. समझ में आ रही है आपको? You
ठीक
understand?
है.
Nazir Khan?
Yes, yes. Yes,
हाँ, तो
yes, sure.
तो bill for example, let's say Asim, you get busy. After Nexus, after the next let's say 90 days is over, all of you have got excellent opportunities. You guys are making money, but you're also working with us. Now, I will not delete your account. I will go ahead and lock your account because I know that tomorrow I may have to say, Asim, I need you to come back as a user. Mubarak, I need you to come back as a user. Let me unlock your account. Make sense?
Yes.
I don't
Okay.
have to delete you, then start you all over again on all the projects you guys are doing with me. And let's delete all files from Asim. Or let's move them in backup. But yes, we can make a decision. Maybe Asim, mashallah, has built an app, his business is doing good. He's not going to come back and use anything on our resources. Okay, we have a 1-year policy. We have waited for 1 year. Let's delete the user. Let's back up the files and completely delete the user. You see what I'm saying? So many things
Yes,
can be
sir.
done that way. So this is the whole game about identity thing. Okay, hold on a second. Right. So lock and lock. I have a little bit of So lock and unlock. Right. Easy peasy commands. Easy peasy commands. Delete the user. Very good. User delete. RMDIR. I'm gonna remove that little 20th January. Some commands on group check. Don't worry about them. How do you add a group? Very simple. Add user to the groups. We've just done that. User add tester user. Tell this. There you go. So I've done a little thing for you there. Now, you guys can read on this. We will not spend time on this. CH8, this is actually, you're tested on the Red Hat exam on this. Okay. Simply, if you have to make some changes, we just give you some quiz. It's nothing you need to memorize. It's really something you prepare before the exam, right? So if you want to change some parameters, like in the Red Hat exam, they say, okay, we have a user Tom, and we need you to change some things on that user. Okay. For example, minimum number of days between password change. Can you change that? Okay. Uh, there are different flags. These are the two common questions on the Red Hat exam. That's why I have them actually. So minimum number of days between password change, 0. Maximum number of days between password change. Okay. So the Red Hat exam can ask you to change any of these things, make the password inactive, uh, account expire. They don't go this far, but they come within the first 4 on the top. So this is a summary of what this is Red Hat exam. Okay. Take a look at the etclogin.def file. We are going to talk about it more. We are going to talk about how it has your UMask, it has your home directory, UID, GID, password aging controls. So it has these bunch of things that I've just easily put for you. So the final one is LS logins. So you had your job and you say LS logins Tom. So username is Tom. This is UID 1003, home directory, shell, no login, no password is logged, no password not required, no login by password disabled, encryption method, okay, primary group QA, GID, supplementary groups SRC, supplementary group IDs 1008. So pretty much like an audits, password expiration warning interval 7. maximum change time. So the CHAGE command will help us change these parameters. So this is a very powerful command, ls login for Tom, for lab user. So it gives you a quick snapshot. Everything we have learned, just run ls logins lab, and we have pretty much, if you want to know what should we learn, memorize ls logins lab user or your user you have. And now you can go through and say, okay, how do I change this? How do I modify this? What happens? So we have covered essentially user management today very successfully, ladies and gentlemen. I have no further things to discuss today with you. I'll reload this with any changes today. We'll get started with um, some work tomorrow. We have file system management, SE Linux. We're going to get into some nice stuff that we're going to learn. And I hope you enjoyed this class. And I hope you will continue to not lose heart. Stay with us. And let's get to the finish line. Thank you so much. If you have any questions, I'm open to questions.
Yeah, thank you so much. I really appreciate your approach to teaching. Jazakumullah khaira.
Wayakum, wayakum.
Thank you, Nadeem bhai.
Thank you, Nadine.
Yeah, very, very welcome. You're welcome.
May Allah
Yeah.
continue to enrich you in knowledge.
Ameen, ameen, ameen.
Yeah, I want to ask this question to ensure I have the right knowledge.
Please go ahead. I'm open to
Yeah.
questions.
The concept of group, I see it as uh, a group of users into an entity.
Right.
Like when you have because like you have primary group, you have
Let me show you. Let's go ahead. We'll talk. Let's keep this slide in front of us, and let's look at let's understand it. Let's put this in front of us. Okay, go ahead. Yep. What's your
Okay.
question now? Oh,
So
wait a minute.
now,
One
because
second.
in the context of permission, I
Yep.
used to see you have the root user and the user and the group. So when you have permission that is for the group, that means every body in that group that belongs to
We're
that
coming
group.
tomorrow. We're coming tomorrow. Very good. Very good. You're thinking about tomorrow.
Okay.
There are some crossovers that I need to be careful about. That is why it takes me a lot of time to dissect it. So I've confined you to just think about simple commands to create a user, add a user, modify a user's ability to be in multiple groups, and we leave it at that for now. Because when we get into permissions, meaning, like what you're saying, your question is, ladies and gentlemen, is a very good question, excellent, brilliant question. If, for example, the person in the middle that I haven't named in this picture, right? You look at this this person in the middle. Okay. So let us say that Maria, let's use Maria, we have a name here. So we say Maria is part of two groups. Okay. She's part of Linux team. Okay. And she's also part of DevOps, correct? But she's not a part of developers, right? She's not a part of this group. That's not what she's of. This group goes and creates directories, okay? And this group creates a bunch of files, okay? So a bunch of files this group has created, the developers. What we are going to learn is that Maria can actually view these system-wide files. All these files are in the same system. Everybody is sharing the machine, okay? If the developers are using the same machine, the same environment, She's able to see the files, but can she make changes to the files? That's the question. And if Maria is creating some files, and she does not want, let's say, Khadija. She does not want Khadija to come and delete this file accidentally. Okay? Or Khadija is working on a directory and file, and she does not want Maria to come and delete her work. All of this is part of what we're going to study tomorrow, which is permissions. That is where we're going to look at DAC, and then we're going to look at MAC, and then we're going to look at RBAC. RBAC. So tomorrow's topic is going to be on DAC. I hope, and I really hope that we can wrap it up tomorrow so that we can load you with the work Monday, Tuesday, Wednesday, Thursday, Friday. You can get this out of the way. So your question will be answered tomorrow. And I believe you're asking a question like that. That what if she has a file? Can she do something with that file? And what if they all have a group files and the other group cannot delete it? What if in the group, one person creates it, can the others view it and can they delete it? Only he creates a file, he's the lead, or John is the lead, or Srini is the lead in this group. And what can Maria do? So we're going to look at the blue box. We're going to look at the green box. We're going to look at the brown box. And we're going to play with these boxes to see what happens. Does that make sense? Because they're all of them have files. Everyone here has a file. But can John modify Maria's file? Can Maria modify John's file? Can she delete it? Can he execute it? Whose permissions? What permissions does she give? And then on top of all of this, the blue is the root. The green is the root. The boundary is root. Root has access to everybody here, right? So tomorrow we will see that.
Okay, thank you.
You're very welcome. You're very welcome. Very good question. So when we get into permissions, that's the fun part. I have separated permissions from this so that you are not confused at all. You can open day Saturday, Monday, Tuesday next week. You can just simply do user add, group add, user mod, simple stuff, cmanage, things that will get you very grounded in separating your mind from this file permission problems. How do I have, because the Red Hat exam is testing you on this. Your ability you must be like a master in file permissions. That is, you're tested on that. So I've separated that completely as a different module to teach so that your mind is very free, focused, and easy on executing what we have studied today. All right. If there are no further questions,